Let's see what happened to US Treasury yield curves at the end of 2016, okay, only recently. So here is a graph of what happened from November 8, 2016, the yield curve, to the end of December 20, 2016, to the yield curve of US Treasury bonds, okay? So here are the times to maturity, 1 month, 3 months, 6 months. So these are Treasury bills, 1 year, 2 year, 3 year, and so on. And 20 years and 30 years, in the middle you have the Treasury notes, and at the end you have the Treasury bonds, okay? These are the yields, and the time to maturity you have here. We recorded what are the yields, and we put the dots, and then we created those lines, connected the dots. As you can see, the yield curve has changed, and it didn't change in a parallel way. So for short-term maturity, very short-term to maturity bond, the yield has increased slightly, just slightly. For a little bit longer time to maturity, the yield hasn't changed, or hasn't changed by much, okay? But after that, the curve has started to set apart from the original yield curve. So this is a typical behavior. It may change in a parallel shift, and it may change in a non-parallel shift. Reinvestment risk. Reinvestment risk is the risk for fixed income holders, buyers, that the proceeds, the coupons that you collect on the way, received from the payment of interest and principals, that are available for reinvestment must be reinvested at a lower interest rate than the security that generated the proceeds. So think about the following scenario. You buy a bond and you collect coupons. Now you need to do something with the coupons on the way. Let's say that the par value, you will collect them only in 10 years or 15 years or 20 years. On the way you collect maybe semi-annually coupons. Those coupons, you want to do something with them. You don't want to keep them in the bank and earn zero interest rate. So what many bondholders, investors are doing is they reinvest those coupons, accumulated coupons, and buy new bonds with them. So the thing is that if you will buy new bonds with a lower interest rates, in fact you're buying bonds with lower yield, lower return, or vice versa. You can say that you're buying bonds at a higher price. Now, this is obviously a risk because you reinvest the coupons and then you get less and less every time if the interest rate comes down. This is called the reinvestment risk. Zero coupon bonds clearly have no reinvestment risk simply because there are no coupon payments to reinvest. So for zero coupon bonds, there is no reinvestment risk. But for coupon bonds, yes, there is a reinvestment risk. In general, we say that the lower the coupon rate, the greater the interest rate risk for two bonds with the same maturity, but the lower the reinvestment risk. Okay? So reinvestment risk works in the opposite direction of reinvestment risk. Higher interest rate risk creates low reinvestment risk, and low interest rate risk creates high reinvestment risk. Let's see a couple of examples. First of all, conceptually, reinvestment risk, we say that, look, let's say that the interest rate comes down over time. So let's say that you have $1,000 to invest. First, you get 10% return. So after 1 year, you will get the principal times 1 plus the interest rate of 10%. You will end up with $1,100. The second year, for some reason, the interest rate comes down. This is the reinvestment risk. So simply you take the $1,100 that you have right now at the end of year 1 and you reinvest it at a lower interest rate, now 5%. So take the $1,100 times 1 plus the interest rate and you get only $1,155. Altogether, what is your total return over those 2 years? You take the amount received minus the amount invested divided by the amount invested. So altogether, over 2 years, you earned only 15.5%. Obviously, the investor now loses from a change in the interest rate, simply because the interest rate went down. So you don't earn as much as you expected. Maybe you thought that you will get 10% in year number 1 and 10% in year number 2, and you didn't get that. So this is conceptually the reinvestment risk. Let's see another example with bonds. Okay? So let's say that we have a bond with a $1,000 a bond with a coupon rate of 10% paid annually for 10 years. So you collect $100 every year for 10 years, and in the end you will collect the par value of $1,000 plus the last coupon of $100. Initially, the yield is quoted as 11%, and therefore the bond should be at discount. Whenever the yield is higher than the coupon, the bond is at discount, and you can calculate the bond price as $941.11. That's originally. And the yield curve is flat. Prior to the payment of the next coupon, immediately just before the first coupon is being paid, we consider what happens in three different scenarios. If the yield curve will shift parallel down to 9%, from 11% to 9%, that's a shift down by 2%. If the yield curve remains the same, flat at 11%, and also what happens if the interest rate goes up by 1%, okay? Will shift parallel up to 12% from 11%, that's an increment of 1%. Let's see the math here. So the face value or the par value of the bond is $1,000, 10% coupons nominal paid annually, and right now the interest rate or the yield is quoted as 11%. So let's see what the bond's price right now. The cash flows along the years are the following. Year number 1, 2, 3, 4, all the way to 10 years until maturity. The coupons will be 100, 100, 100 all the way. And at the end, you will collect the par value or the face value, $1,000 plus the last coupon, another $100. So altogether, you're expecting to receive $1,100. We can discount those coupons to present time either by simply dividing it by 1 plus the interest rate every time, by 1 plus 11%, or we can create here the discount factor just to illustrate this point. Discount factor is simply the 1 divided by 1 plus the interest rate to the power of the time. So discount factor of 0.9009, you can calculate it as 1 over 1.11 to the power of 1. The discount factor in year number 2, 0.8116, if you want, this is the 1 over 1.11 to the power of 2 square. Discount factor of 0.7312, this is 1 over 1 plus 11%, 1.11 to the power of 3, and so on and so forth. So the discount factor is just a name to create this reciprocal of 1 plus the interest rate to the power of the number of years. And the DCF, the discounted cash flow, you take the $100 and you multiply times the discount factor. So alternatively, you can also do the 100 times 0.9009 or 100 divided by 1.11 to the power of 1. 100 times the discount factor at year number 2, 0.8116, will give you 81.16, or you can do also $100 divided by 1.11 square. You will get the same thing. Okay, so these are the discounted cash flows, and eventually if you will add all the present value of the future cash flows, you will get exactly the bond's price as $941.11, exactly as we already found out. Okay, so this is the current situation. Now, on the next panel, on the right-hand panel, we consider what will happen to the yield curve if it will go up, if it will go down to 9%, if it will stay the same as 11%, and if it will go up to 12%. So this column represents the 9%, this column represents the 11%, and this column represents the 12%. But in every column, what I'm calculating is not the present value, I'm actually calculating the future value of those coupons. The reinvestment risk actually affects your future value, how much money you will end up with. So let's see the story. If the interest rate will move down to 9%, remember that we're expecting that the interest rate will change just immediately prior to the next coupon payment, to the first coupon payment. So if a second before the first coupon payment has changed to 9%, there are still 9 more years until maturity. Not 10, but 9, because right now we're 1 second before the first coupon is being paid at the end of the first year. So you take the $100 coupon, and you multiply times 1.09 to the power of 9. This is how you get this future value. If the interest rate is changing to 9%, then there are still 9 more years until maturity. For the second year, you're expecting to receive $100, and there are still 8 more years until maturity. So with a 9% new interest rate, you take $100 times 1.09 to the power of 8. There are 8 more years until maturity, and you will get 199.26, and so on and so forth. Obviously, at the end, at year 10, at the day of maturity, it doesn't matter, you multiply times, you don't need to multiply times anything, or if you want, you multiply times 1.0, whatever the interest rate is, to the power of 0, because this is exactly at the day of maturity. So the $1,100 will remain both here, here, and here. And eventually we sum all of those future values of the coupons and the par value and the last coupon. We add all the future values both for the 9%, the 11% and the 12%, and this is how much you are expecting to end up with. Those are the future values. Once we know the future values, you can calculate, and obviously you can clearly see that for higher interest rate, the future values are bigger than for mid interest rate, which are also bigger than for low interest rate, for 9% interest rate. This is just based on the time value of money. With higher interest rate, the money will grow more. Now, once you know the future values for each and every accumulated coupons and par value, you can simply calculate the yield to maturity. So for example, the 10.35%, you take the future value which takes place after 10 years, divide it by the initial amount invested, the 941.11, and then account for the 10 years until maturity. Same thing for the 11%, same thing for the 12%. As you can see, when the interest rate is going down to 9%, the yield to maturity, your overall return, is lower than for 11% and for 12%. So obviously, the reinvestment risk here is expressed as when the interest rate goes down over time, your overall return goes down. When the interest rate remains the same as 11%, your yield to maturity will remain as 11%, as you expected. That's the original interest rates or the yield to maturity for the bond. And when the interest rate goes up, this is actually not a reinvestment risk. That's actually good for you, because if you will hold it until maturity, then you're expecting to receive even more yield to maturity than you expected. So this is not a reinvestment risk. Here, there is no reinvestment risk simply because you got exactly what you wanted to. And over here, this is the reinvestment risk. Your overall return went down simply because the interest rate went down and you had to reinvest the coupons along the way at a lower interest rate, and therefore you received lower future cash flows, which accumulate to a lower amount at the end.